on multidimensional mobility and intelligent adaptability rather than sheer acceleration or minimalist aesthetics. Positioned as BYD's flagship, the U7 also signals a larger shift in Chinese innovation within the luxury EV space, which has long been dominated by Western brands relying on strong branding but relatively incremental technical advancements. BYD's approach emphasizes practical innovation and mobility intelligence over traditional luxury hallmarks like premium interiors or brand prestige. The fact that these features are production-ready, rather than experimental concepts, makes the U7 a particularly disruptive entrant. Could this mark a broader movement toward valuing function-driven luxury over conventional status symbols? BYD's unveiling of the Yangwang U7 marks a bold declaration of its ambition to not just compete with, but potentially surpass, established luxury electric vehicle (EV) brands. While its performance in international markets remains uncertain, particularly amid ongoing trade tensions and regulatory complexities, the U7's release clearly demonstrates BYD's forward-looking strategy. This vehicle is more than just another premium EV, it embodies the pinnacle of BYD's technological innovation and hints at the future of luxury mobility, where software integration, autonomous capabilities, and adaptability redefine what premium truly means. In this evolving landscape, BYD's daring vision could very well set the new industry benchmark. At the heart of BYD's most advanced offerings lies the revolutionary e-platform, a four-motor independent drive system that reimagines the dynamics of electric vehicles. Unlike traditional setups that rely on one or two motors, E-equips each wheel with its own motor, enabling fully independent torque vectoring. This allows for unmatched precision in power distribution, balance, and responsiveness. The focus isn't merely on delivering raw speed, but on achieving refined, intelligent control over every movement, essentially mastering motion itself. Beyond its theoretical advantages, the E-platform has proven its real-world capabilities. In Moose tests, designed to assess obstacle avoidance at high speeds, vehicles using this platform achieved a record 95.78 km per hour, demonstrating remarkable agility and safety. Additionally, the system supports advanced maneuvers like automated in-place U-turns without gear shifts or braking, and lateral movement, enabling the car to slide sideways out of tight spaces with as little as 30 centimeters of clearance. The system is equipped with multiple driving modes tailored for various environments, such as big stride for rapid lateral repositioning and small step for precise maneuvering in tight or crowded spaces, ideal for urban driving and compact parking structures. In terms of safety and fault tolerance, the E-platform is designed not just with redundancy in mind, but with true resilience. In the event of a tire blowout, the remaining motors can dynamically redistribute torque to maintain vehicle stability, even during diagonal blowout scenarios at speeds of up to 160 km per hour. This adaptive control ensures the vehicle remains operable in situations that would typically disable conventional cars. Enhanced by intelligent systems, distributed control, and advanced fault isolation, the E-platform redefines expectations for high-performance electric drivetrains. It also supports fail operational capabilities, allowing the vehicle to safely complete its journey even if one or more drive components fail, an essential feature for autonomous and semi-autonomous driving. What sets the E apart is its scalability. It's not restricted to a single luxury model but can be adapted across BYD's entire lineup, from flagship models like the U7 to future mass-market vehicles. Seamless integration with BYD's other systems, such as the Yun-Nian Z suspension and the Magic Ruler sensor suite, creates a tightly connected feedback and control network. As the automotive industry shifts from mechanical systems to software-defined vehicles, the E-platform could signify a transformative design philosophy, one where motion is programmable, precision-driven, and deeply intelligent. The real question is no longer whether this technology works, but how quickly the rest of the industry can catch up. At the core of BYD's effort to revolutionize ride comfort and vehicle stability lies the Yun-Nian Z system, an intelligent suspension body control technology inspired by the principles of magnetic levitation. This groundbreaking innovation, developed over 7 years by a team of more than 10,000 engineers, marks a fundamental shift in how vehicles engage with the road. Unlike traditional mechanical suspension setups, Yun-Nian Z employs direct drive suspension motors that control vertical movement with extraordinary speed and accuracy, delivering a maglev-like smoothness to passenger cars. Its standout feature is an industry-leading 5 millisecond response time, allowing up to 12 suspension adjustments while traversing a single speed bump at 30 km per hour, far surpassing the mere 0.5 adjustments typical of conventional active systems. The system also achieves 1 mm height adjustment precision, enabling complex motion tasks like drawing characters with the car's chassis or moving in synchronized, robotic-like patterns. However, Yun-Nian Z's capabilities extend well beyond demonstration. It offers a driving experience defined by zero bounce, zero pitch, and zero roll, even on uneven terrain. More importantly, the system incorporates adaptive safety features that respond dynamically to road conditions and potential collisions. In the event of a side impact, for example, the suspension can lift one side of the vehicle instantly to redirect crash forces to stronger structural zones, significantly reducing injury risk. It can also handle advanced maneuvers such as climbing curbs or descending stairs with minimal vibration, thanks to real-time load sensing and force redistribution. These functions represent an unprecedented integration of suspension and safety systems, an achievement that conventional chassis platforms have yet to match. What truly sets Yun-Nian Z apart is its reimagining of suspension not as a passive or reactive component, but as an active, intelligent layer within the vehicle's ecosystem. As the automotive industry transitions toward software-defined vehicles and real-time adaptability, BYD presents a compelling vision of what ride quality can mean in the electric vehicle era. This innovation may signal the beginning of a broader shift away from traditional shock absorbers and springs toward intelligent, motor-driven suspension systems. If BYD's technology proves consistent across different models and markets, it could mark a turning point for the industry. At the heart of this transformation lies a small yet groundbreaking component with outsized impact, the magic ruler sensor. This highly precise displacement sensor, central to BYD's intelligent suspension and body control system, utilizes 3D Hall effect technology to monitor the vehicle's posture and vertical movement with exceptional accuracy. Capable of capturing vehicle motion 4,000 times in the blink of an eye at intervals as fast as 50 microseconds, it operates 20 times faster than most conventional sensors. Its ultra-fine resolution of 15 microns, far smaller than a human hair or even a red blood cell, enables a level of responsiveness that borders on surgical precision. This high-resolution feedback forms the backbone of BYD's advanced systems, such as the Yun-Nian Z, allowing the vehicle to adapt instantly to road conditions, suspension travel, and body pitch. Beyond comfort and dynamic performance, the magic ruler sensor has significant implications for autonomous driving and real-time AI decision-making. As vehicles grow more intelligent, the speed and granularity of data collection become critical to ensuring safety. With its ability to detect minute changes in chassis posture or road gradient thousands of times per second, the system can make real-time adjustments to torque, suspension stiffness, or braking, without relying solely on predictive models. In doing so, it closes the loop between sensing and action, delivering a level of control and responsiveness rarely seen in mainstream production vehicles. As BYD expands its advanced driving systems and L3-level redundancy architecture across its vehicle lineup, one quiet but pivotal component, known as the magic ruler, could emerge as the unsung hero powering many of the brand's most intelligent features. This technology prompts a broader question for the industry: could ultra-high-resolution sensing be the missing link in achieving safe, human-like driving behavior in autonomous vehicles? While technologies like LiDAR and radar typically dominate discussions around autonomy, BYD's focus on precise, micro-level vertical sensing signals a shift toward a new frontier, one where the smartest vehicles are also the most physically aware of their environment. With the industry steadily approaching true vehicle autonomy, redundancy has become a fundamental pillar of safety, and BYD is at the forefront of this movement. The Yangwang U7 marks a significant milestone as the world's first mass-produced car equipped with full L3-level redundancy across four essential systems: steering, braking, driving, and power. In a world where a single software glitch or component failure could lead to disastrous outcomes, BYD's architecture is designed to ensure core vehicle functionality remains intact even in the face of failure. This fail-safe approach isn't just innovative, it's crucial for the realization of fully autonomous driving. Central to this safety strategy is BYD's God's Eye intelligent sensing suite, which comes standard even on non-premium models. Featuring a trio of laser units and powered by dual NVIDIA Orin X chips delivering a combined 508 TOPS of processing capability, this system works alongside 32 high-performance sensors. These include LiDAR units with 128 line-point cloud resolution and a range of up to 200 meters, offering a highly detailed, panoramic view of the vehicle's environment. The result is an advanced perception system that not only matches but in some cases exceeds those found in many of the world's top-tier electric vehicles. BYD has made a remarkable showcase of its system's capabilities, particularly during the autonomous Moose test. The Yangwang U7 demonstrated exceptional control, maintaining stability at speeds exceeding 95 km per hour, even during extreme evasive maneuvers. This stability, seen in tight slalom courses and sudden obstacles, highlights more than just solid design. It's the result of intelligent torque and brake redistribution enabled by the E4 platform and L3 safety stack. In the event of a steering or brake failure, the system can maintain control by utilizing the vehicle's independent motors and redundant power supplies, ensuring safety until the vehicle comes to a complete stop. What truly sets BYD apart is its nationwide rollout of urban autonomous navigation. Unlike competitors who lock such features behind subscription models or regional restrictions, BYD's autonomous driving is ready for use at the point of delivery. While regulators continue to define full autonomy, BYD's hardware and software already meet the requirements for a Level 3 autonomous future. As cities become more crowded and driving conditions more unpredictable, BYD's commitment to comprehensive redundancy could set a new global benchmark for intelligent safety systems, potentially leaving other automakers scrambling to catch up. In another industry-shaking move, BYD recently unveiled a 30,511 RPM electric motor, one of the fastest mass-produced drive units in the automotive world. With the ability to deliver 580 kilowatts of power per module, this motor doesn't just set new records, it exceeds expectations. What makes it even more surprising is that it's being introduced in BYD's mid-tier Han L sedan and Tang L SUV, rather than in a hypercar. To put it in perspective, this motor outperforms even the Xiaomi SU7 Ultra's 27,200 RPM motor and the Tesla Model S Plaid's 20,000 RPM motor, both of which are designed for high-performance segments. BYD's engineering approach is as advanced as the performance numbers indicate. The motor incorporates N50EH high-energy magnets, boosting magnetic performance by 18%, while its 10-layer short-distance winding design reduces copper loss by 21%. Additionally, the motor uses a 0.2 mm ultra-thin silicon steel sheet to minimize iron loss, and features direct refrigerant cooling for enhanced efficiency. BYD has not only optimized the motor for peak performance but also for long-lasting, efficient power delivery. Precision in dynamic balance has been refined to just 50 milligrams, half the industry standard, further improving stability and safety at high speeds. The motor is also integrated with BYD's 1500V silicon carbide power module, which allows for higher voltage tolerance and improved thermal efficiency, both of which are crucial for achieving superior high-speed performance and durability. What's particularly noteworthy, however, is the decision to introduce this powertrain in family-oriented models. The Han L accelerates from 0 to 100 km per hour in just 2.7 seconds, while the Tang L SUV achieves the same feat in 3.6 seconds, times usually associated with exotic sports cars. Even more impressive is the Han L's 100 to 200 km per hour acceleration time of just 4.74 seconds, and the Tang LS 6.19 seconds, performances that rival dedicated track vehicles. While this significantly boosts BYD's technical credibility, it has also sparked online debate: is such speed suitable for everyday drivers? Some users have raised concerns about safety, especially regarding whether average drivers, accustomed to more conventional vehicles like the Honda CR-V, can safely manage such high-performance capabilities. Comparisons are being drawn between BYD's strategy and Xiaomi's, as both require users to unlock high-speed modes through practice trials. This raises the question of whether BYD will follow the same path. The debate surrounding this technology has become a hot topic in the electric vehicle (EV) community. Some see it as a bold move toward democratizing performance, while others view it as a case of technology surplus. This shift is also reflective of a broader trend in the Chinese auto market, where consumers are increasingly expecting cutting-edge features even in family and commuter vehicles. Regardless of the perspective, this move highlights BYD's engineering expertise and confidence. By offering high-performance capabilities in models designed for everyday use, BYD is challenging the traditional segmentation of power, price, and practicality. If successful, this could reshape consumer expectations not only for premium buyers but also for anyone seeking an electric car that delivers both excitement and advanced technology. In another groundbreaking development, BYD has introduced a 1000-volt charging system that could redefine EV convenience. Promising to deliver a full charge in just 5 minutes, this system represents a significant leap over Tesla's Supercharger V3, which typically takes 15 minutes for a similar charge. This innovation is more than just an improvement in battery input rates, it is a bold statement from BYD that ultra-fast charging is no longer a futuristic idea but a near-term reality. This announcement comes at a time when consumer demand is increasingly focused on practicality and charging speed, alongside driving range. It also showcases BYD's ambitions not only to lead in EV hardware but to actively shape the future of charging infrastructure. In doing so, BYD is directly challenging Tesla and legacy performance brands like Porsche, whose Taycan once set the benchmark for charging speed. The potential implications of this development are immense. For urban commuters, taxi fleets, logistics operators, and road trip travelers alike, the ability to fully charge an electric vehicle, EV, in the same amount of time it takes to grab a coffee removes one of the last significant barriers to EV ownership. However, this breakthrough also raises important questions about infrastructure readiness. Can public charging networks and local power grids accommodate the high voltage and current demands of such systems on a large scale? If BYD's ecosystem is designed to support this advanced charging architecture from the ground up, it could quickly set the company apart in competitive markets, particularly where quick charger turnover is crucial. Reports indicate that BYD has already begun working with utility providers and urban planners in key regions to roll out compatible charging stations, potentially creating an integrated ecosystem that can grow and scale in both urban and rural areas. Technically, achieving this milestone requires more than just high-powered cables. It is expected that BYD has leveraged its vertically integrated supply chain to design specialized battery packs, cooling systems, and silicon carbide (SiC) power modules that can handle extreme energy transfer safely while maintaining long-term performance. The company's in-house battery innovation, particularly its Blade battery, already offers enhanced thermal stability and fast charging capabilities, making it an ideal match for the 1000-volt system. New thermal management techniques, such as direct refrigerant cooling, advanced thermal interface materials, and multipath dissipation, are likely to ensure both safety and longevity despite the high charging intensity. If this technology proves effective for mass-market applications, it could disrupt the current industry focus, where most companies aim for a 10 to 15-minute charging time. Reducing charging to 5 minutes would represent more than just a technical achievement, it would signify a shift toward refueling parities with gas stations. In an industry where software updates and self-driving advancements often take center stage, BYD's charging innovation highlights a different type of progress, one rooted in infrastructure, engineering, and a focus on improving the user experience. BYD's focus on technology could solidify its position as a leader not only in EV hardware but also in the broader conversation surrounding electrification efficiency. By ensuring its ultra-fast charging system is compatible with both current and future vehicle models, including more affordable options like the Qin L, BYD is positioning itself for widespread adoption rather than catering to a niche market. The question now is whether other automakers, including Porsche, will quickly adapt or if BYD's first-mover advantage will allow it to redefine the expectations for modern EV charging experiences. Regardless, the standard has certainly been raised. As BYD continues to advance on the tech front, a more intricate race is unfolding globally, one where innovation intersects with geopolitical tensions. As BYD's growth accelerates, the global EV landscape is increasingly influenced by geopolitics. While Tesla faces backlash due to Elon Musk's controversial political associations, such as his ties to Donald Trump's re-election campaign and interactions with far-right groups in Europe, BYD has largely stayed out of political controversies. Instead, the Chinese automaker has positioned itself as a disciplined, tech-focused alternative, steadily expanding its international presence while maintaining a low political profile. This approach is becoming more significant in markets where political neutrality is valued as a brand asset rather than a liability. BYD's branding strategy, which emphasizes technology, sustainability, and innovation over political affiliations, resonates with both regulators and consumers seeking stability in an increasingly polarized world. However, BYD is not immune to geopolitical friction. Growing trade tensions between China and Western economies have resulted in heightened scrutiny and potential tariff threats, especially in the United States and the European Union. Concerns surrounding supply chain dominance, data privacy, and national security have triggered regulatory investigations and the possibility of sweeping policy changes. In response, BYD has begun relocating parts of its manufacturing operations abroad, with plans to establish passenger car and battery factories in countries such as Thailand, Brazil, and Hungary to localize production and minimize its exposure to future trade barriers. BYD's strategic growth is propelled by its partnerships with regional governments and infrastructure providers, enabling the company to establish a strong presence in markets with growing demand for electric vehicles, EVs, and limited political resistance. What sets BYD apart in a politically charged environment is its broad institutional backing and long-term vision. With a significant stake held by Warren Buffett's Berkshire Hathaway, though reduced from its peak, BYD enjoys global credibility, allowing it to navigate political challenges more effectively than some of its competitors. Furthermore, the company is diversifying its approach by not only exporting vehicles but also key technologies such as battery systems, semiconductor components, and transit solutions. This dual-track strategy, expanding both hardware offerings and technology licensing, reduces dependence on any single regional market. For example, BYD's Blade battery is already being supplied to other automakers, including Toyota, positioning the company as a potential foundational player in the global EV ecosystem, contributing not just through vehicles but through critical infrastructure and components. Looking to the future, BYD's global ambitions seem to be shifting from a market-by-market expansion to reshaping the global EV supply chain. If Chinese EVs face increased resistance in Western markets, BYD may turn its focus to BRICS nations, Latin America, or Africa, regions historically underdeveloped by Western automakers. Alternatively, joint ventures with legacy automakers or energy companies could become a key strategy to co-develop infrastructure in regions where neither party could thrive alone. One thing is clear, BYD is no longer just a Chinese EV manufacturer, it is emerging as a significant geopolitical player in the future of mobility. With scalable platforms like intelligent technologies such as Yun-Nian, and breakthrough innovations in powertrains, BYD is not only leading in innovation but also strategically positioning itself on the global stage.